just like we did for arithmetic sequences, we are going to try to derive a formula for the nth term of a geometric sequence. And we're going to do it the same way. We're going to try to write out the first few terms and look for a pattern. So it says if A1 is the first term of a geometric sequence and R is the common ratio, then the terms of this sequence are given as follows. We're going to let A1 just stay A1. We have to start somewhere, okay? And then to get A2, all we need to do is take the term that came before it, which is A1, and multiply by the common ratio R, okay? So A2 is just A1 times R, okay? And then to get A3, we need to take the term that came before it, which is A2, and multiply it by the common ratio. Okay, so it's going to be A2 times R, but we know a formula for A2. Okay, we said A2 is the same thing as A1 times R, so we're going to make that substitution. Okay, so A2 is the same thing as A1 times R. Okay, so that's the piece in yellow. Everything in yellow is equivalent. So we've got A2, which is A1 times R. We have to multiply it by another instance of R. Okay, so basically A3 is calculated by doing A1 times R squared. Okay, and then we do this again. Okay, basically we're trying to write each term in terms of A1, the first term, and R, the common ratio. Okay, if we look at A4, to get that, we need to take A3, the term that came before it, and multiply by R. Okay, again, we know how to get A3. Okay, we just said that A3 is the same thing as A1 times R squared. So we're going to make that replacement. Okay, A3 is what's in blue. It's A1 times R squared. Okay, but then we need to multiply that by another instance of R. Okay, so if we simplify this, A4 is going to be A1 times R squared times R. That's just going to be R cubed. All right, continuing on, we'll do this a couple more times, okay? And then you should see the pattern if you don't already, okay? To get A5, we need to take the term that came before it, which is A4, and multiply by the common ratio, okay? We know how to get A4, okay? A4 is the same thing as A1 times R cubed, okay? So we're going to replace that in this piece, okay? So to get A5, it's A4. A4 is the same thing as A1 times R cubed. Okay, so the green pieces are equivalent. Okay, and then we've got to take the A4 and multiply by another instance of R. So A5 just turns out to be A1 times R cubed times R. That's just R to the fourth. Okay. All right, one more time. In doing A6, to get that, we need to take A5, that's the term that came before it, and multiply by R. Okay, we know how to get A5. A5 is A1 times R to the fourth. Okay, we're going to make that replacement right here. So A to the fifth is the same thing as A1 times R to the fourth. Okay, the stuff in purple is equivalent. Okay, so you need to take the A5 value and multiply by R. So we need to multiply this purple quantity by another instance of R. So A6 is the same thing as A1, the first term, times R to the fourth times R, which is R to the fifth. Okay, so there is your way of getting A6. All right, so now we should hopefully see the pattern. Okay, so if we go back and look at this, A1 is A1, but A2 is this guy, and let me go back and box. We're going to be looking at the end game. Okay, so what we got at the end here. Okay, so this, okay, and then we're going to be looking at this. Okay, we're just looking at what we got at the very end. Okay, so each of these guys tells you how to get the specific term using the A1 value and the R value. Okay, so notice each of these terms involves A1. Okay, to get a certain term, we're multiplying A1 by some power of R. Okay, but what is the power of R? Well, remember, if we're looking at these terms, okay, we're trying to do this in terms of an n value. If this is the first term, n would be 1. For the second term, n is 2, n is 3, and so on. Okay, So we're trying to write our formula in terms of the n value here. Okay, so like we said, we see in all of these a1 times the power of r. Okay, so let's see how that power of r relates to the n value. Okay, so let's start with n equals 3 because the powers are a little easier to see. Okay, so basically if n is 3, if we're on the third term, the power of r is n minus 1. Okay, so that's basically 3 minus 1, which is 2. Okay, so it seems like the power on r is going to be n minus 1. Okay, if we check the others, this seems to hold. If we go to the fourth term where n is 4, okay, the power on r is indeed n minus 1. It's 4 minus 1, which is 3. Okay, that holds here as well. Okay, if we move on to the fifth term to compute a5, the power on r is n minus 1, or 5 minus 1, which is 4. And then it even holds for the last term here. For n equals 6, the sixth term, the power on r is n minus 1, 6 minus 1, which is 5. Okay, it holds for these other two. Okay, so don't worry, the power on r here is 1. Okay, so if your n value is 2, if you're on the second term, that's 2 minus 1, or 1. Okay, it works. Okay, so this is the pattern we're seeing. Okay, so this is the formula we're going to end up using for the nth term of a geometric sequence. It is given by an, that's going to be equal to a1. You need to take the first term and multiply by a power of r. The power of r is n minus 1. Okay, this is summarized in the box below. To compute the nth term of a geometric sequence, it says in a geometric sequence with first term a1 and common ratio r, the nth term an is given by the following. Okay, an is a1 times the r value raised to the n minus 1 power.